Hello and welcome to my channel. This lecture is about the medulla oblongata, so let's begin. The medulla oblongata is the caudal part of the brainstem. It continues at the spinal cord in the vertebral canal. That's why the spinal cord sometimes is called the medulla spinalis, because it's an extension of the medulla oblongata. This region is the medulla oblongata, as you can see here. It's 3 centimeters long, extends from above the atlas till the lower border of the pons. This is the C1 nerve, so the medulla oblongata begins here. Anterior there is the basio-occiput, posterior the cerebellar notch of the tentorium cerebelli. Superior it has the pons, and inferior is the spinal cord. As you can see here, the anterior median fissure, and it's interrupted in the middle because of the crossing. See this interruption of the fissure, because this is the crossing of the corticospinal tract from the left side to the right and from the right side to the left. It has the pyramid, then the anterolateral sulcus. Behind the anterolateral sulcus is the olive. This is the olive, and behind the olive is the posterolateral sulcus, then the inferior cerebellar peduncle. So the pyramid, the anterolateral sulcus, the olive, the posterolateral sulcus, then the inferior cerebellar peduncle. And note that from the anterolateral sulcus, I mean between the pyramid and the olive, emerges the hypoglossal nerve. This is the hypoglossal nerve, while posterior to the olive, between the olive and the inferior cerebellar peduncle, nerves of 9, 10, 11, glossopharyngeal, vagus, and accessory nerve emerging from behind the olive, as you can see here, 9, 10, 11. Don't confuse that with the hypoglossal nerve, which emerges anterior to the olive. It has the open and closed parts, means the part not involved in the fourth ventricle is the closed part, and the part which forms the lower part of the floor of the fourth ventricle is called the open part of the, or the open medulla. From posterior aspect, you can identify the gracile and cuneate tubercles and tracts posteriorly. We saw that with the anatomy of the fourth ventricle. And here again, these are the gracile and cuneate tubercles. The gracile is most medial, cuneate is lateral to it, and see, this region is called the open medulla, which forms the lower part of the floor of the fourth ventricle. This is the fourth ventricle. This belongs to the pons from here upwards. This is the facial colliculus, so this is the pons part, and this is the medulla or medullary part, and the inferior cerebellar peduncle is evident here. Okay, to be oriented with this diagram, this is the fourth ventricle, middle cerebellar peduncle, superior medullary velum, superior cerebellar peduncle, the corpora quadrigemina, which are the superior colliculi and inferior colliculi on the back of the midbrain. This is the superior brachium going to the lateral geniculate body, and inferior brachium going to the medial geniculate body. See that? Inferior brachium. This is the pineal gland, and this is the thalamus and pulvinar part of the thalamus, which is the posterior part, and this is the third ventricle between the two thalami. The internal structure of the pons of the medulla oblongata. This is the closed medulla, lower part at the level of the motor decussation. it has ascending and descending tracts, the same as those of the spinal cord, and level of sensory decussation. This is the level of sensory decussation. See that? Here you have the gracile nucleus and the cuneate nucleus. Okay? And this is the cuneate tract. The gracile tract will be here. These are the internal arcuate fibers, which will form the medial lemniscus in the middle eventually. This is part of the spinal nucleus of the trigeminal and tract. This is the accessory cuneate nucleus. It's called the accessory cuneate nucleus. And here we have the medial lemniscus and the MLF. And here this is the pyramid and part of the inferior olivary nucleus. So at the level of sensory decussation, we saw the pyramids, gracile and cuneate tracts, accessory cuneate nucleus, spinal nucleus of the trigeminal. See the spinal nucleus of the trigeminal also present in the motor decussation. It's very evident here. And internal arcuate fibers. The internal arcuate fibers, they will form as you go up. So you will see it in the sensory decussation section. These are the internal arcuate fibers. At the level of motor decussation, we have the gracile nucleus and tract, cuneate nucleus and tract. See, remember again, the white matter is black and the gray matter is white. In this dyeing technique. Spinal nucleus of the trigeminal. This is the spinal nucleus of trigeminal. Pyramidal decussation, you can see that the pyramids are decussating. This is a decussation. And while decussating, they detach the anterior horn of C1, of the beginning of the spinal cord. See that? This is a detached anterior horn of the gray matter of the spinal cord. This is the level of sensory decussation. And the nuclei in the medulla, we have the gracile and cuneate nuclei. They form tubercles at the back. The hypoglossal nucleus and the nucleus ambiguous, it's connected to the 9, 10, and 11 nerves, the glossopharyngeal and vagus and the accessory nerve, nucleus ambiguous. The dorsal motor nucleus of the vagus is present also. The solitary nucleus and tract, the nucleus and tractus solitarius, and the cochlear and vestibular nuclei, the trigeminal nuclei that form the trigeminal thalamic tracts, they cross and go to the thalamus. This is a section of the open medulla. This is the nucleus solitarius, as you can see here. Okay. Here you will find the hypoglossal nucleus and the nucleus of the vagus lateral to it. And this is the MLF and the medial lemniscus. This is a higher level than the two sections we saw before. This is the inferior olivary nucleus here. And this is the inferior cerebellar peduncle with 9, 10, 11 nerves emerging, and the hypoglossal nerve you can see emerges from this area. This is the fourth ventricle. Okay, this forms the hypoglossal trigone, and lateral to it is the vagal trigone, and then the nucleus solitarius with its tract. The nucleus ambiguous also in this area. In the open medulla, this is the open medulla. We can see the inferior cerebellar peduncle, inferior olivary nucleus, and the pyramid. This is the pyramid here. In the middle part, we can see the medial lemniscus and the MLF in this area. In the posterior part, we can see the vestibular nuclei, the hypoglossal nucleus, and the dorsal motor nucleus of vagus. Laterally is, as I told you before, is the nucleus ambiguous and solitary nucleus or nucleus solitarius, and spinal nucleus of the trigeminal nerve. The reticular formation nuclei, there is a nucleus parvocellularis and a nucleus called nucleus reticularis gigantocellularis. Nucleus reticularis gigantocellularis. Also, the tracts entering the medulla are the gracile and cuneate tracts, the spiny olivary tract, and cortico and rubro-olivary tracts. They form together the central tegmental tract, spiny olivary and cortico and rubro-olivary, on their way to the olivary nucleus, the one you see here. And tracts originating like the cuneo and olivocerebellar tracts, the olivospinal, vestibulospinal, and lateral reticulospinal tracts, and the reticulothalamic tract, which is the central tegmental tract, or the CTT. Nuclei which are connected to cerebellum are the inferior olivary nucleus. It's very evident here. It receives the central tegmental tract from the corpus striatum. Remember, the corpus striatum is the part of the lentiform and caudate nucleus that joins anteriorly, and the red nucleus and the cortex. This is the components of the CTT. Also, the accessory olivary nucleus, medial and dorsal, accessory olivary nuclei, they receive spino-olivary tract. Also, the accessory cuneate nucleus, we saw it in a previous section, receives proprioception from the upper limbs through the cuneate fasciculus. The arcuate nucleus is ventral to the pyramid. This is part of it, the arcuate nucleus, ventral to the pyramid, and it's considered as displaced pontine nuclei from the pons above. They receive the corticopontine fibers, and through the arcuatocerebellar fibers form the stria medullaris that curves around posteriorly. All the above nuclei descend fibers to the cerebellum and form the inferior cerebellar peduncle. Reticular formation nucleus, as I told you before, the nucleus reticularis gigantocellularis. So this is a section of the open medulla, and this is part of the cerebellum here showing. Okay. The blood supply of the medulla from the vertebral artery, medullary branches, direct medullary branches from the vertebral artery, anterior and posterior spinal arteries, which are branches of the vertebral artery, and the posterior inferior cerebellar artery, which is a branch from the vertebral artery. And we will get to them when we study the cerebellum. Some lesions of the medulla oblongata, lesion of the medullary branches that come off the vertebral artery involve the hypoglossal nerve, so ipsilateral involvement of the Hypoglossal nerve means half of the tongue at the side of the lesion is involved. And crossed hemiplegia because of involvement of the pyramid. The pyramid contains the corticospinal tract, which is the main motor pathway from the cortex to the rest of the body. It's called the Aryan syndrome and or hypoglossal hemiplegia alternans. Hypoglossal because the hypoglossal on the same side and the corticospinal involves the crossed hemiplegia or the contralateral hemiplegia. Lesions of the pica, posterior inferior cerebellar artery, it's called the Wallenberg syndrome. It's somewhat lateral in the medulla. It involves the inferior cerebellar peduncle, so there will be cerebellar ataxia. Trigeminal nuclei, so involvement of sensations, decreased sensations from the face or the head, and nuclei ambiguous and solitarius and motor nuclei of the vagus, which are autonomic nuclei. Bulbar paralysis, paralysis of the palate. You will find the uvula deviates to the opposite side of the lesion, and cerebellar ataxia because of the involvement of the inferior cerebellar peduncle deviates to the side of the lesion, and positive Babinski sign indicating affection of the extrapyramidal system. You know, when you rub a sharp object or pointed object on the sole of foot, you will notice fanning of the toes instead of flexion of the toes. You notice fanning of the toes. This is a positive Babinski sign that indicates affection of the extrapyramidal system. You will get the extrapyramidal system when we study the spinal cord tracts. And also there is decreased sensations from the face because of the involvement of the trigeminal nuclei. I hope you got the maximum benefit from this lecture, and thank you very much for watching.